Hey guys, how many liters of hydrogen can you collect over water at 752 millimeters of mercury at 21 degrees Celsius if you react 3.566 grams of zinc in excess hydrochloric acid according to this reaction? They tell you that the vapor pressure of water is 18.65 millimeters of mercury at that same temperature. How do you find the volume of a gas in liters? I only know of one way to do that, really. And that's with the ideal gas law. The volume is nRT divided by P. All we need to do is find the numbers for each of these variables. Now the number of moles is going to come from the fact that we're reacting 3.566 grams of zinc. Zinc itself, the number of moles of zinc I should say, is going to be the mass divided by the molar mass. 3.566 grams divided by the molar mass of zinc, which according to my periodic table here is, man, why is this so small? 65.39 grams per mole. On the calculator, that turns out to be 0.05453 moles of zinc being reacted. What we have to do is figure out how much hydrogen we're going to get from that. Luckily for us, we get one hydrogen from every single zinc, so the number of moles of hydrogen is also 0.05453. That's the N that we're going to plug into this formula. R is a constant, we know what it is. T is a constant, we know what it is. What pressure of hydrogen are we going to collect? Well, it says the pressure is 752, but it also says it's collected over water. Over water means that water contributes a little bit to the total pressure. This value that they gave you, the total pressure, already includes 18.65 millimeter mgs of the water, because water has a vapor pressure. It's kind of volatile. The pressure of hydrogen is actually the difference between those two. It's the total pressure 752, but you take away 18.65 to account for the fact that there's water mixed in. Water vapor mixed in, I should say. 752 minus 18.65 gives 733.35. Oh, well, we got to convert that to ATM as well. I'll do that in this formula as we're plugging the numbers in. So, I got my N, I got my R, I got my T, and I've got my P. So, I can just plug it right into the formula. What color haven't I used yet? I've used them all. The total volume of hydrogen that we're going to get is number of moles, 0.05453. R is always 0.08206. Temperature, 21 degrees Celsius, but let's convert that to Kelvin by adding 273. And the pressure, 733.35, but we got to convert that to atmospheres. So I'm going to divide it by 760. That's the conversion rate to go from millimeters of mercury, aka torr, to atmospheres. So here we go. It's calculation time. I want you to be able to see what I'm doing here. 0.05453 times 0.08206 times whatever you get when you add 273 to 21, apparently 294, and then you divide it by the pressure, which is 733.35 divided by 760. I guess it's 0.965 atmospheres. And the answer that I get here is 1.36 liters. I hope that's a choice in the multiple choice question. And there it is. When you collect hydrogen over water at this pressure and temperature using 3.566 grams of zinc as your limiting reagent, you're going to end up with this many moles of hydrogen, which corresponds to this volume at that temperature and pressure. Hey, best of luck in your own collecting over water limiting reagent problems.